Right. So hello and good morning to all of you, those who have joined. A quick check. If I'm audible, please confirm by typing in the chat window if I'm audible. I can see a lot of participants have already joined in. Wonderful. Okay. So let's start with the proceeding. First of all, thanks so much for to all of you for taking your time out and joining the webinar on a Sunday morning. It's great to see a huge participation, right? So shows the interest in this topic. Yeah, I mean, definitely as a part of our IIQF series of webinars on like industry experts. So today's webinar topic is careers in artificial intelligence in finance, particularly, right? And this is definitely a very important topic. AI and machine learning and data science, these are huge buzzwords in any case. And our industry of in finance, particularly the advanced analytical areas of finance, is no different. I mean, a lot of breaking work is happening in this field, and I mean, it's a very exciting times actually. So yeah, I mean, in that realm is today's discussion to understand the career opportunities in this field in finance, and also maybe to understand briefly how to go about all that, right? So without further ado, I mean, today's session will be conducted by Mr. Sanjay Bhatia, and I mean, first of all, once again a formal thank you, Sanjay, for joining in.
Thanks a lot, Nitish.
Right. So just to briefly introduce Sanjay. Sanjay has done his MBA in finance and also has an MSc in machine learning and artificial intelligence from Liverpool John Moores University. He also has a postgraduate diploma in machine learning and AI from IIIT-Bangalore. Currently working as a director with UBS in their risk modeling and analytics. So where he has also handles model risk management and control, and in the CRO chief risk office function. Sanjay overall has more than 15 years of mainstay experience, particularly in risk management, risk models, and methodology space, encompassing Basel, advanced AIRB, IFRS 9, IM, MEM, and SSECR, exposure, XBA, FRTB, OTC derivative pricing, and other advanced modeling topics. Previously, he has worked with various other foreign banks, Barclays, RBS, Citi, Credit Suisse, mostly in the risk consulting domain. So, I mean, he is somebody who has been in the forefront. I mean, in this industry, with combining machine learning and finance, right? Particularly in risk management. So, who better than him to take us through this topic? Sanjay is also very passionate about imparting practical model understanding and insights, and has been a professional trainer for corporate and investment banks. He's one of our lead trainers as well, particularly in the machine learning and artificial AI areas. So his area of interest are credit and counterparty credit risk, market risk, stress testing, stochastic modeling, quantitative finance, and machine learning. Right. So with that, I'll hand over the session to Sanjay. But before I do that, maybe just a brief laydown on how we would proceed with the session. So the main talk will be about like maybe about 50 minutes or so, and then we will briefly introduce you to the various work that we have been also doing in like this space, particularly in terms of education in advanced machine learning and AI and other areas. And then we would have the Q&A, right? So Q&A, I mean, we would want the session to be as interactive as possible, right? So, I mean, please feel free to type in your questions, queries, whatever questions that comes to your mind in realm of today's discussion. Please feel free to type in. We would like the session to be as interactive as possible. And I mean, given the fact that like the participation is huge, so unfortunately, we would not be able to unmute you and allow you to speak up. But nonetheless, please feel free to type all your questions, and we'll try to take up each and every question, right? So with that, I mean, let me hand over the session to Sanjay. Sanjay, I just make the presenter. Yes. So I think you are the presenter.
I hope you can see my screen. If you can confirm, maybe.
Yes, yes, absolutely.
Okay. Let me maybe put it on the deck presentation mode.
Right.
Yep. Okay. So thanks everyone. First of all, being part of such exciting sessions, which we generally maybe conduct to create a broader participation as well as interest building and eliciting on these hot topics, which are not only just some kind of passing fade or trend, but rather bringing some kind of a tectonic shift in the way financial industry sectors, especially fintech driven revolution, is changing the landscape, right? So today's topic, as rightly Nitish has introduced, is all about the AI careers, artificial intelligence careers in finance. And basically, before moving on to the moot point of the topic, discussing the different career roles, trajectories, what are different career options, what is career pathing, what kind of skill set are required for somebody to prosper and at least start out and see themselves 5 years down the line, playing a role in artificial intelligence in a financial application or use case. We will cover a bit of a groundwork right here for people to understand what is the overarching thing about AI, what this buzzword is all about, and what is how to disambiguate this buzzword to be more clear and crisp about what it means, right? Especially in the context of finance and financial careers, right? So the first thing is that maybe last maybe decade and more than a decade and a half has been into data revolution. And with that uh, I mean that we have seen a data wave or a tsunami of data which has been very unprecedented, and the volumes of data the variety of data, the veracity of data, as well as the uh, validity of data has changed a lot. So we have seen quite a huge volumes of data. The such a huge volumes of data is coming at a high frequency or high velocity, right? So that is the second V of big data: huge volume, huge very frequent velocity, or very ferocious velocity. The third V is veracity of data. That data, whatever is coming and flowing through different new sources, modern sources, is difficult to validate, right? That is a challenge with the new form of data, right? And then maybe also the fact that maybe such a data comes in very large variety, right? We are not typically talking about the traditional or conventional form of data, which is just the numerical data or a time series data. We are here talking about broadly imaging data, text data, right? Tweet data, or maybe the signal data, IoT data, all different kind of modern data forms. And these modern data forms need to be mined properly. So we will talk about the data mining skills and the data mining careers and the big data platforms. But the genesis of AI is which particular business model will mine this huge data to maybe come out with some useful insights into the data, and then maybe design some kind of a autonomous algorithms or decision making systems on top of it, right? So that is the key advantage which most of the fintech firms are trying to fold for themselves. They are trying to disrupt the market by mining the data, especially this new form of data, be it by volume, by variety, by velocity, or by veracity, right? And then maybe trying to create some customized autonomous self-learning, self-automated, or self-calibrated, self-parameterized models who can maybe dynamically programmed to build some insights out of this new data. So there are obviously many promising aspects, and it's not just a passing fade or a passing trend, or maybe just so as to be ignored, right? This is rather a tectonic shift, and the which will bring about maybe the change in the business model, the rebooting of the old brick and mortar business model of running the banks, or running the financial institution, running the funds, right? And this is a changing a lot. This is leaving a lot of mark, and rather a dent on the typically old stereotype kind of a organization which we have seen so far. The new form of organization is very nimble, right? Very much autonomously driven by these algorithms, very much rely on data to make the decisions, rather than any kind of hypothesis or any kind of assumptions about data. It relies on data rather than statistics coming from the historical analysis of the data. It look at the data in its current form and the emerging form, and build these algorithms. So that's the new norm or new reality, so to say. And there are many promising prospects of AI, which, as a somebody who is trying to build a career into this, should be aware of. What are the promising maybe features or characteristics of AI, and why this change is so unavoidable, and maybe so much so that one need to definitely build a skill there, right? And also take that skill as a lifelong skill, because it is going to stay forever, and it is going to change the way the financial world operates as on date. The promising aspects or prospects of AI is that they are built out of data driven way of building any model, right? So previously the old statistical or mathematical models were mostly assumptions driven, theoretical conceptualization driven. So you have seen about modern portfolio theory, or maybe arbitrage pricing theory, or maybe all these different theory, the risk return, maybe utility curve theory or utility maximization theory. So these economic theories, or econometric foundation of the models, as well as some of the financial theory and portfolio theories combined together, make a lot of assumptions about the data, right? The data is normal or Gaussian distributed, it is log normally distributed, it is this distributed. They try to retrofit the data in some kind of a normal family of distributions. But how these new data driven models and algorithms they are designed is that you need not to pre-programmed or pre-assumed any form of distribution, how the underlying data is distributed. The data will come, the algorithm will automatically calibrate to the distribution, whatever it is, whether it is a normal or some kind of a non-normal distribution. Whatever the data is, whatever its is form or shape or form, there's no assumptive way of modeling it. The data will tell its own way what kind of how it is distributed and what kind of empirical distribution it hold in the market. And by saying that, mere that thing, it means that we are not trying to manifest a new kind of reality, which is kind of a normally distributed world, which is any which way not the case, given the kind of globalized world we live in, and where every then and now we see one financial crisis or the other, right? We are far away from normal times. And definitely data will be liberated to tell its own story, where maybe a AI expert would definitely try to mine this data, build up a story, try to visualize this data, drive some intuitions and insights from the data, and then take a decision which particular AI technology or AI technique would best suit that particular data or use case or problem statement, right? So this is a completely different way or different approach to building models and algorithms than how we used to build conventionally. And this is quite contemporary way, right? The second aspect of data is that specifically with financial data, the financial time series, you have must have seen volatility series, you must have seen price pricing series, many financial time series across different asset classes, that they have a different characteristics of very low signal to noise ratio. It means that the financial time series is very very noisy. It has a lot of noise. By noise we mean that it has a lot of perturbations, lot of disturbances, lot of noise, lot of extraneous effects, lot of latent variables, lot of unobservable random variables. And all these put together make the financial time series very noisy for any data set which is used or harnessed for modeling purposes. Now having said that, one should it is pretty much clear for people to understand that uh, for a traditional model, no matter how you built it, the first big task is doing a lot of data manipulation to clean up that particular noise from the data. And that is done manually. That is a very very rigorous task, where somebody spends 60 to 70% of the model development time or model built out time just to cleanse the data, just to manipulate the data, just to transform the data, just to prepare the data for modeling purposes or modeling use, right? So this denoising of data is automated within machine learning. So machine learning is very good, or maybe the AI techniques are very good at detecting patterns, finding anomalies in data, finding outliers in data, finding certain things which are spurious correlations in data, right? Which give you a sort of distorted picture of what the real relationship is. So all these things can be easily handled within the machine learning, or specifically within the AI techniques. So that is another upside or promising prospects of AI. The third one is, as I alluded to implicitly, that the machine learning is all about building autonomous decision systems or intelligent algorithms. But what does that really means? What is the cornerstone of saying something is autonomous? Now, in the current regime, when you build a model, it's a lifetime exercise, right? The model uh, uh, building doesn't stop as a one-off exercise. Every year after year, you recalibrate the model, you reparameterize the model, you reevaluate the model, you revalidate the model, you try to keep tracking the performance of the model, monitor it, uh, and every then and now when the data changes, you have to one has to go back, a quantitative modeler has to go back and redo the model, right? Be it changing its parameters, changing its coefficients, rerunning the regression, rerunning the time series, rerunning the classifiers, all of that, right? But and also then recalibrate the model, right? Obviously, when the data changes, like any default data change or recovery data change or any volatility change in the market, would kick in a kind of a recalibration where the model need to just align to the new reality. So that's recalibration, how the model output could be matched with the actual data, right? Actual real outcome in the market, the true value. So that kind of exercise is pretty much many manual laden, and has a manual touch point, and it is a repetitive exercise, which is a regular periodic exercise, which under the machine learning or AI is completely autonomous. So once you build these models, these are free spirited models, so to put them analogously, that in a sense that they will automatically recalibrate themselves, automatically reparameterize themselves. Hence the basic definition of AI starts with building such kind of algorithm which require the least degree of intervention, least degree of programming, right, going forward, right? So AI, genesis of AI is from with the same, with a very basic premise that building some kind of a modeling capability or some kind of analytics capability which doesn't need to be programmed at all. That was the godfathers of AI said that a machine which need not to be programmed, once learned, it will function by itself, right? So that's where it's a huge advantage, and it's such a potentially disruptive force of AI that once these models are built, they are dynamically recalibrated, dynamically parameterized, dynamically reevaluated, dynamically on the real time. They pick up the any changes in the underlying distributions of data, right? They dynamically adjust themselves, they dynamically revalidate themselves. So a lot of these dynamicity is brought into the design of the model, right? The next thing is, obviously, that the time series has obviously any financial time series, not just one, has a we always enforce a thing on time series that it is a stationary, it is homoscedastic. The term homoscedastic means, homo means same, right? Scadastic means distribution. Its distribution is non-time variant. It is stationary over time. Once you assume a distribution or analyze a distribution, the seasonality, the cyclicality, the variation in these seasonality, cyclicality pattern in the data more or less remains the same. It is not that time varying. It is a stationary distribution. But is it a right assumption? Isn't it that this is very stringent or sticky assumption for a model, when especially the times we are living in, very when every then and now one crisis travel from one part of the globe across the Atlantic, and make rounds of the entire earth, right? And maybe make the entire globe facing the domino effect of one thing which started elsewhere, which has nothing to do as part of market interconnectedness, but it will travel across. Is this the time to have such an assumption that the data is non-stationary, has non-stationarity or homoscedasticity. No. So machine learning is very adept, or AI is very adept as at uh, finding wherever the data is non-stationary, wherever it has a heteroscedasticity, means its distribution, its dispersion changes with time, right? It is a time varying distribution, right? It evolves through time, right? So that's another feature which AI is very good at. And obviously, you know uh, then also I'll couple it with other, you know very promising maybe aspect of AI, that is a non-linear decomposition. Like, a lot of the relationship which you examine between what your target or dependent variable on one side and your set of independent covariates on another side, you assume linearity. Your regression is entirely based on linearity. The conventional modeling assumes in one way, implicitly, explicitly, directly, indirectly, right? Inherently, some form of a simplifying reality called linearity, right? But today's data is telling us a different story, that most of the relationships are curvilinear. They are polynomial characteristics, and they are high degree polynomials, right? And obviously, for these high degree polynomials, you need such a mathematical functions which could literally build the relationship in the model, or pattern in the model, in a non-linear way. So decompose the non-linearity and build a model in such a way so that the non-linearity could be accounted for, right? And that's where AI comes into foreplay, right? Uh, and other aspects is, anyway, all these things being said, that machine learning is very good at handling large amount of data. Not only data big in volume, but data coming at a ferocious high velocity, data coming in variety, like maybe your textual data, your maybe video data, your speech data, your maybe low orbiting satellite signal data, your IoT devices data, uh, your Twitter data, your social media data, a variety of this data. The machine learning has the capability to process this kind of data, which is not there at all in the conventional statistical models, right? So with all these being said, one point maybe which I forgot to mention here, machine learning is also very good at solving high dimensional problem, and today and future problems are literally high dimensional. Suppose if you go and take a simple decision, uh, on what basis being a fintech or a company or a bank or a peer-to-peer lending company, on what basis I should give a loan to an SME, right? Or to a HNWI, high net worth individual. That decision in itself is not limited to few variables. Now you got to see that how you could assess the climate risk or climate and sustainability risk of that SME. You have to take another set of variables which will reflect the carbon footprinting of that particular SME, small and medium enterprise. You got to see for an HNWI what is their lifestyle score. From where you will get it obviously from multiple social media sites, how they, you know through their posts, by understanding what kind of pictures they post, what kind of lifestyle expenditure they have, assigning them a lifestyle score. So all these things, right? With respect to SME, the cyber security or the fraud risk, right? Or the non-compliance risk, or maybe there are other aspects you have to take into account. So this dimension, this throws the problem into a higher dimensional problem. High dimensional problem means I don't simply have 10, 20, 25 variables. I rather have 50 and hundreds of them, right? And machine learning is very good at solving high dimensional problems, considering so many variables at one time without the need for assuming that there's no multicollinearity, there's no interaction between these variable. Machine learning uh, models or AI models are very good at handling this multicollinearity effect, right? Right. So not only non-linearity, but multicollinearity, not only non-stationarity or heteroscedasticity, but also handling the noisy, denoising the data. So a lot of these things are playing out, and that is changing the reality, how we model things, how we build intelligent machines, how we build our future decision system, what would be the design thinking around that, and what is the basis of this design thinking. So these are not just some kind of a cliche kind of thing. These are real things which are bringing about this radical change, transformation of moving away from doing a typical statistical modeling, right, in a stereotypical presumptive way, to build a data driven, free of assumption, free of theory modeling. That's the new paradigm. And but there are, obviously, when there are so many advantages, there are pitfalls as well, and that goes with every damn thing, right? So pitfalls of AI are, right, they are very data hungry machines, and it's just that their appetite is very high. The amount of data which is required to train or to maybe build a model, the statistical model, the machine learning algorithm is at least 3 to 12, at least, sorry, not 3, 10 to 12 times, it requires more data to build the same kind of algorithm in machine learning. If you compare a typical OLS, or maybe some kind of a regression, MLE regression, ordinary least square, or a maximum likelihood estimation kind of a regression, right, in statistical way. Comparably, if you do a ridge and lasso and elastic net regression in AI or machine learning, it will require obviously far more data, right? Similarly, logistic regression versus support vector machine, or maybe a decision or not, rather a decision tree, but a sort of any kind of probability regression, or any kind of classifier under the conventional statistical method versus a random forest or extreme boosting machines, right? They require far more data. They are data hungry, I would rather say, not machines but monsters, right? Okay, so that obviously is a challenge which constrained the progress, because some of the small firms, right, who haven't literally invested a lot in building this big data platform and big data capability, would be at the receiving end of that uh, on the wrong side of this, because they obviously will struggle, right? And the data is uh, is the most precious commodity, more than oil and more than gold or more than any precious metal in today's world, in this digitization age. Whosoever can nail it, they nail the business model. So that's the reality. The other aspect is, because this model brings out the patterns right from the data, without making any theoretical formation around that, or theoretical framework around that. Whatever data tells, they will pick those patterns and build a relationship out of that. They sometimes tend to overlearn or overfit. Overfitting or overlearning tendency means that they sometimes get sticky with data. The, the, the kind of data you build a model on, right, it should not be a prison for the model, because every time the data would change, the model is expected to perform similarly, irrespective of whether you do some prediction on the data from which the model is estimated or developed, or you do prediction on a new data, like your portfolio changes, your customer base changes, your market strategy changes, right? Your generally onboarded some new segment in your portfolio which was never before. You acquire a new firm and you have some inorganic growth. The kind of base uh, they have and the kind of base you have, is entirely different. So your model should work on any kind of data. It is a universal model, right? It is not just built for one data set or one portfolio, right? Given that, within the definition of the portfolio, no matter how the data changes here, there, everywhere, the model should perform similarly. But the problem with the machine learning models, and then there are certain methods how to control for the overfitting and overlearning of a machine learning AI model, which is very data sticky, right? So they are very overfitting and overlearning. They also have a look ahead bias or data leakage, what we call it. Look ahead bias means this thing that without looking at too much of the history, they try to predict for the future, right? Obviously they are not wrong in doing that, because one should not have historical bias, right? Because every time, the distribution is changing, the data is changing, right? The markets are changing, the market realities are changing. There are new alternative assets which are coming into foreplay, like cryptocurrencies and all, right? There are new uh, kind of form of carbon trading happening, or green bonds coming. There's a lot of things which are changing in the market, but obviously history definitely cannot be assumed to repeat itself, but history is still a reasonable indicator of the future. So they generally have a look ahead bias and data leakage, because uh, some of the historical data, though the traditional models or the typical statistical models have a historical bias, they have a forward bias. Machine learning model have a forward bias, which is beneficial as well, which is sometimes a pitfall as well, that whatever the Basel says, that build model out of uh, Basel AIRB guidelines, advanced internal rating by base guidelines, or even advanced model guidelines, says that build a model from the your own historical experience. So that thing somehow maybe is not uh, well, you know uh, consistent with a machine learning model, because machine learning model would always have a look forward bias or look ahead bias, right? And it might lead to some historical data leakages, it might not build some pattern on the historical precedences and all of that. The last but not the least, the biggest challenge is, and these three are still manageable challenge, because we have a waste within AI tool sets or AI techniques to handle the data requirements, by synthesizing more data to allow them to not to overfit or not to overlearn, by controlling how they parameterize, and by influencing the design of the algorithm to control their behavior, not to overlearn from the data. Look ahead bias, by using some kind of a introducing some kind of historical bias to manage, to balance it out with the look forward bias. But the last thing is a matter of AI research, which is called explainable AI. Generally in the market, and many of the people who have not gone into the nitty gritties of the machine learning methodology, they for them these models are completely black box. How to make them gray box, and how to move towards them a white box, right? That's the question. So there's a field of AI research which we call explainable AI, and a lot of uh, academic careers, a lot of new industry roles are specially designed around explainable AI. We have AI models. Just explain the output of AI model to my regulator, to my auditor, to my model validator, to my model governance team, to all the stakeholders, to my chief investment officer, to my chief risk officer, to my chief financial officer. Explain it to everyone, right? For different reasons, because it's not just about taking some decisions, but also backing those decisions with some sound basis on which such kind of decisions are taken. You obviously have to redraft your policy, right? And redraft your credit underwriting standards and trade analysis standards, all of that, right? Basis some understanding of these models. And that's where AI explainability and performance attribution, right? If AI is predicting something, how you would attribute it to, what kind of reasoning you would attribute to, that's an area of research. And that's an area where it's not that we generally the market or industry isn't, or academia is non-starter. We have made a quite a good progress and covered the ground, because we have the application of game theory there, right? Game theory is being applied. And if you have heard of something called Shapley values, Shap explanation, that is based on game theory, right? Uh, Game theory, right? So that's basically, that is coming a lot forward in order to explain the models, to tell which variable contributed what part of the prediction, to what an extent a variable which is which is part of the model contributed to the explanation of the model, or like a prediction of the model, right? That is going there. We, a lot of AI research and techniques have been introduced, they are debated, there are many literature papers, they are in the circles to of many symposiums and many such focus discussions, seminars, to further consolidate that and build those techniques and adopt those techniques for AI adoption, right? So that's where things are. So generally, AI and data science and AI ML, they are part of the same what you call maybe a wagon, right? Same wagon, wheel and wagon, right? In a sense that data science uh, creates modelable data set, irrespective of whether machine learning algorithms will harness them or not. The data scientist's role comes out to be work on alternative data set, all kind of data set, right? Work on alternative data set and keep them ready, right? In one way or the other, AI ML role family focus on finding the right kind of AI ML techniques to be applied to those data set which are already processed, which are already made ready to go to the model kind of a state by the data scientist. So that's the difference. Data scientist is heavily involved in creation of data set, preparation of data set, augmentation of data set for modeling purposes, for AI modeling purposes. And AML expert, on the other hand, do their technique building, do their technique adoption or technique tweaking, right? To understand, based on data science insights, what kind of technique should be applied to that problem set or data set, and which alternative techniques could be applied, and how they compare the results, how they compare with the traditional or conventional method, and how to explain them better, so that they could be used as a benchmark model, they could be used as a challenger model, they could be used as a challenger model, they could be also used as internal model for somebody who doesn't have the regulatory acceptance. So far as maybe the current formation is that even regulators are evolving, they are coming out with regtech, a different wing or a different dedicated IT arm, or uh, you know the advanced AI machine learning arm of regulators, be it prudential regulatory authority, or be it FINMA, or be it Fed Reserve. They are also coming out with a different kind of a setting or different kind of a specialized outfit, which we call the regtech, to address the issues and to examine, evaluate, approve, and put some regulation around the AIML models. So the market ecosystem is evolving. On one side, fintech companies are getting more share of the markets, be it peer-to-peer lending, community banking, retail banking, wealth management, your uh, private banking space, investment banking, front office, valuation and pricing, trading, all these you have their footmarks everywhere. So they are getting more share. And on the other side, the regulator is creating an ecosystem where such models and such business models, which are based on such AI ML algorithm, could be well accepted in the market and could be well judged and well controlled, well governed from a regulatory perspective. So that ecosystem is getting created, and once we are there, it's not far for anyone to understand that it's just something like this, that somebody got the uh, spirits are already there, adrenal rush is already there. The contest, what is remaining is that somebody should channelize that, right? And the channelization require a regulation, right? Once that regulation is created, you would see that all these fence sitters and criticizers and maybe speculators, or these cynicist people who say, or pessimist people who say that what could AIML do in an area called finance, they would be proven wrong someday, right? I'm not boosting about AIML, but generally this is my gut feeling that the direction of travel is there, right? They will be proven wrong because it is going to come. It is imminent reality, right? It is sure to happen, and it's not just today, it's for last few years that we are seeing it being imminent, and it's being adopted even by those banks who are big elephants. They would never dance in a while being trapped in a room, but they are still dancing to the tunes of AI because there's a thing to it. They are being threatened by the ascendance of the fintech companies, which are becoming the challenger bank themselves. So tomorrow the reality would not be different, that if Google or Amazon will apply for a fintech license, they would have enough money, they would have enough data to create a bank, or a analogous bank which is bigger in proportion to your Goldman Sachs or Morgan Stanley's or JP Morgan's or UBS or Credit Suisse of the world, obviously, right? And given the technology, it would not take a decade. It would just be a matter of few years that the market could be disrupted, the market business model could be disrupted, right? How customers are onboarded, how customers, what kind of product design are created based on customized strategies. It could really nail it down, right? So that's the reality under which we are working. But let me maybe uh, cover a bit of ground. What kind of roles are we talking about? Because after all, our session is also about giving people a navigation, right? Which, obviously, the journey is more important than destination, but keeping a view on the destination, right, will make you understand that which particular territory I should passion more based on where I am coming from, right? What kind of inherent skills I have, inherent interest I have, right? And where should I align more? So it's not like the ages when IT and computerization grown up, and it created its own ruckus and wave, where people were very uh, you know uh, very doubtful about maybe what would happen. This is the same age. This is similar kind of a thing where general masses would have the right to react, because there's a lot of buzz, and that buzz is also around the fact that it would cut down jobs. It would bring down the kind of a people-led organization to a robotic organization, which would be driven by these intelligent machine, and it would not require people anymore. But there's a to some degree, yes, there's a slight fact to that, but not it is overbeaten, right? Because AI ML creates in itself so many roles, right? That the stagnancy in the market of typical roles has been maybe long been there, and they have been stagnant, with packages being stagnant, with compensation stagnant, entry level packages stagnant for different kind of role families within the typical IT role families, or ITES role families, or some kind of a product research role families, all kind of consulting role families, or even in bank some kind of a back office, middle office, or front office role families. The stagnancy there has been forever, right? Like I have spent career, you guys are, even you have much more experience than me, right? You have seen that last 8-9 years we have been pretty much stagnant. If you do the CPI inflation adjusted, right, growth in your packages, or growth in the any entry level package, or any new role package, it is negative rather, right? So it is already there that we are going down a downward slope unless something new kind of roles are created, which will be very futuristic, like it would you know cut across multi decades to come, right? And this is the answer, right? So artificial intelligence, data science, machine learning, they are not just a bunch of rules. First of all, I just want to maybe dequel your fear, maybe, or even doubts, that okay, it's just one rule. It's in itself a variety of rules which will cater to everyone, right? Not only that, we somebody who is good with programming, who is good with mathematics, who is good with statistics, who is good with probability, who is a domain expert in a particular area, we require all kind of people, but those kind of people also need to understand that they need to obviously understand the AI ML well, because they would be working under that umbrella, obviously the new reality, right? Obviously they would be doing more or less the same core thing, but the way they are doing that thing, that would be enabled by AI ML. Their tool sets, their techniques, right? The kind of methods they will adopt, right? That would be coming from the AI ML shelf. Obviously, the business would be conducted in the same way. So portfolio risk is not changing, right? Fund risk is not changing, fund management is not changing, right? M- Trading algorithmic, maybe trading, be it high frequency, they would not change, because the how the trading happens, it happens. How the derivatives are valued or priced, it will be valued or priced more or less similarly, right? It's just a new technique there which they need to understand, and they need to go to the bottom of the mathematics of that technique, the statistics of that technique, the probability of that technique, the programming bit of that technique, to make themselves, to just leverage their existing core competency. Where to go from there? You guys are already SMEs, subject matter experts in your own area, but if there's a new wave coming, obviously you will have to take the skateboard and understand yourself how to do skiing on this new wave, or maybe how to skiing in a new terrain, right? That's just that little thing. It's not that you are not aware about terrain, it's just that instead of just walking down the terrain, you will be going on a skiing, right? You need to understand how to do the skiing, right? So there's nothing to maybe really over bothered and overthinking about it. So what kind of data science skills, data science career roles we are talking about? Obviously data science is not just one role family. It starts with listening about that, okay, data science scientist is a the most uh, uh, most wanted kind of a skill, right, for the next century, right? Obviously that's the fact. But what is data scientist? So data scientist is obviously what I explained, that data science is all about a decision science, drawing decisions, drawing inferences, bringing in new insights, not just from traditional data set but alternative data sets. How to augment the alternative data set, and complementarily bring the traditional and alternative data set together. How to even create new data set through synthetic data, wherever you have the data, the data scarcity, how to create synthesize the new data, right? So all these things bring together, right? Data scientists create new data set, new which could be harness mind, uh, and some kind of use for some kind of a modeling by the AIML guys, right? So data scientist is somebody who is very good with statistics, probability, especially descriptive and inferential statistics, probability, but in a new way, right? Obviously you will say that how then it is different from a traditional somebody who is a statistician and any which way part of maybe the econometrics, or some part of he is any which way doing that, but in a new way, because data scientists would be required to do it on a new data set. As an example, and it is more rigorous on statistics, because previously a data scientist used to assume what, this data is normal, this data is log normal, this data is maybe binomially distributed, this data is maybe some kind of a uh, you know uh, uh, Poisson distribution. Now these 10-15 distribution would not hold. You have to know a lot of extreme value theory distribution, gumbel distribution, because data could come in any form, right? It could be distributed you know you know anyhow, anyway, right? Yeah, in different forms, it can take different forms. And so the reality is that the statistics role has been magnified or amplified, right, to build such kind of a data, right? So you need to be very rigorous with your understanding of statistics and how it is applied to the new form of data. Data analytics, you need to know some of the BI tools, right, including in Python, where you would use some of the potent libraries like matplotlib, pyplot, which allows you to do some very interactive visualization plot, statistical visualization plot, as well as cborn, as well as other different BI tools, right? Which the variety of BI tools which you put together, you need to understand how to visualize this data, how to show this data to my stakeholders or to the decision makers, to my CXOs, to my model developers or model designers or AI designers, to somebody who is an auditor, so to somebody who's a regulator, how to put facts out there, how to bring about insights in a clear and crisp way. So that data analytics is all about creating insights, inferential insights in a summarized way. And what better way to put a picture there, right? So that analytics is all about the data visualization mostly, or data storytelling, right? Synthetic data expert, obviously I explained that we in this world, and with AI model being more data hungry, and with new asset class like cryptocurrency, bitcoins and all, right? They are coming, even green bonds are coming. You don't have data, you don't have historical data, so how to synthesize the data? Because you, any which way, one way or the other, you have to build some kind of intelligent machine to do the prediction on that. Data engineer is somebody who is a techie role about creating big data platform, handling big data, hosting it on big data platform like Scala, Spark, Hadoop, creating the data schema there, right? Building the service oriented architecture and the microservices, right? uh, you know Deploying the data on a cloud, hosting the data on a cloud, right? Also processing of the very modern or unconventional form of data like imaging data, or maybe the textual data or the tweet data or the IoT data or the signals data, right? The low orbiting satellite sending signals, like those kind of data, or geo satellite images, those kind of data, right? uh, Big data platform, I already explained that. So the difference between a data engineer and a big data platform is that big data platform is the uh, somebody who is more involved in the, as a designer, right? As somebody who is a kind of a platform architecture, right? He will take the choice, he will first of all assess the choice, what is the volume of the data or velocity of the data, what kind of data, how many uh, you know exabytes of the data need to be processed, and what kind of choice should be made, or what kind of platform we should build. So these are architectural design. So he's an architect. Data engineer is really who is a coder, who literally code that into some kind of a programming language to create that data platform. Big data owner. Now many of the domain experts, you would have seen BCBS 239, right? Obviously. And it talks about data traceability, data controls, data governance, data lineage, right? Data transparency, data maybe frequency data. So those who are experts in one domain or the other, like somebody is an expert on market risk or credit risk or counterparty credit risk or operation risk or liquidity risk or funding risk or maybe this risk, that risk, right? Or front office pricing, they will be made into data owner, right? They need to hone up, the kind of skill they need to hone up is they need to understand what a data scientist is looking for, right? Right? But the data owner, a data scientist cannot be a data owner because he only understand how to put a statistician hat to the data, how to process the data, how to draw inferential statistics or descriptive statistics from the data, right? How to visualize the data, right? He doesn't understand the domain aspects of the data. So he will sit along a data owner, right? And would understand the domain aspects of that particular data. Even indeed, a data owner would be a stakeholder to him, because once he get few things out of his the statistical analysis on the data, he will check with the data owner whether he's figuring out the right distribution, he's finding the right kind of properties about that particular distribution, whether that data how it's being processed, how it's being augmented with other different variety of data that makes sense. There's a correlation. He will show all the his statistical insights to the data owner as a first stakeholder. So there many of those who are already SME experts, even if they don't understand the programming, they need to understand data science, they need to understand what kind of statistics could be done on a volatility data, right? Right, what is so different about a data science or a machine learning or AI way of doing some kind of analytics on some kind of a volatility data or pricing data or recovery data or default data or different data sets, right? So that's a big data honor what he ought to do in its futuristic role family. Similarly, coming on to the AI machine learning, obviously now the data set has been created, it has been mined, some useful insights, inferences, some kind of a conclusive modeling decisions have been already captured by the way data has been processed, right? Data manipulation, transformations, data cleansing, data aggregation, maybe data treatments like missing value treatment, extreme uh, outlier treatments, or all this has been done by data scientists. Data set is now created, prepared, it is sitting there. Now what a AI or machine learning expert is supposed to do, right? Pick up this data set and try in an experimental researcher fashion, try to not only try to fit one model but try to fit multiple techniques, right? And compare them side by side, right? Some techniques would be good at modeling non-linearity. He need to understand that whether the data, the problem statement uh, is about handling non-linearity, problem statement is about handling heteroscedasticity, problem statement is about handling high dimensionality, problem statement is about handling noisiness in data, problem statement is about synthesizing the data, problem statement is about doing some generative AI application of that particular data so that it could be used to generate something which is not there, right? Some kind of a scenario, right? So all this kind of a thing is essentially the where a artificial intelligence and a machine learning expert comes into the foreplay. So they mathematically understand the technique, right? Right, they also understand the pros and cons and the constraint of that particular technique. They also understand how to handle the misgivings or the pitfalls of machine learning algorithms like a neural network or a deep learning algorithm, right? It is a massive algorithm which is inspired by human uh, you know uh, central nervous system and how neurons work in our body, right? The neurotransmitters work in our body. That model, that deep learning neural network is built to address high dimensional problem, right? Obviously, right? Multi-dimensional or high dimensional problem. But it just because that it is built specifically to address the high dimensional problem, sometimes while addressing the high dimensional problem, it get fixated with data. It means it shows the sign of overlearning and overfitting, right? So how to then handle that aspect, right? Because so these trade-offs, uh, kind of how to adapt a particular AI technique for a particular data set while addressing some of the issues of whether it be a, a particular technique says like support vector machine is completely black box, how to explain it, whether a deep learning algorithm naturally overfit or overlearn, how to address that, right? Whether some models are very data hungry, right? Right. And how to create additional synthetic data to fulfill the requirement of the model, right? So all these things a machine learning expert, because he has finger on the pulse of what that technique, what that AI/ML technique actually wants, how it need to be modulated, adapted, right? And which particular problem set it would work best on, and which particular problem set it is not a right fit. So building model is not about spurious, trying to do unnecessary things. Like, if I know some random forest, don't try to unnecessarily use that random forest for every data, right? Wherever you are building a classifier, no, you should understand that random forest versus a boosting, right, has its own differences, right? If you have some problem where your model is overfitting, like instead of a decision tree you could build a random forest, right? If you have a problem where your model is under predicting or underfitting, then go and try out some xg boost or some kind of boosting technique. So these kind of nuances, right, with the very deep dive understanding into the you know uh, the technical know-how of the technique, as well as the methodology aspect of the technique, as well as the mathematics of the technique, make AI/ML an expert into judging for itself which data set, which technique to map to what kind of problem they are trying to address, and what kind of technique or a set of technique or a hybrid model could work for that kind of problem set. So a lot of these, so we have algo designer, right? AIML algo designer, which to my mind, this algo designer and AIML developer are a bit of roles on technical leaning, right? So those who are coming from IT role family, they could well adapt to these kind of a role, because it requires technical skills, like, right? If I would say that my deep learning algorithm is solving a high dimensional problem, I need to do a distributed computing, or some kind of a thread computing, or train it on multiple GPUs or whatever. So that I need some kind of an IT help to be able to run that model, because it is then predicting on a very high dimensional data set, a very high dimensional problem. And obviously it need to you know estimate a lot of parameters. It is a high parameter space, a lot of parameters, not in few hundreds, but maybe possibly in thousands, right? All the interconnection between different neural network layers and different neurons, it need to you know estimate a lot of parameters. And for that, obviously I need a high computing power. Who will help in that? Algorithm AML algo designer will help in that. So algo designer is something called an architectural expert, who know how to you know create right kind of infrastructure and right kind of computing power, so that that particular AI ML algorithm would be able to do the real time analytics, right? Its runtime would not be high, given it requires adequate amount of processing power, adequate amount of maybe the retrieval logic, or different kind of procedures, IT procedures. So that is the algo design. The AML developer is one level down, who is initially in the beginning of their career. They would obviously need to know the Python modern way of doing the data science or AML, which is right, the modern analytics language like Python, Perl, Julia. Starting with Python is enough, like, right? They would start with Python, and we would require army of developers, right? Because the kind of experiments is going to happen, it would be unbounded. Like, gone were the days when only one technique or maximum two three techniques were compared. Now, coming from the AIML stable or AIML shelf, you would be fitting you know 15 20 techniques, different kind of techniques, or different kind of adaptation of neural network, same neural network but different kind of architecture or design of neural networks on the same data set. So it would require a lot of coding effort, a lot of programming effort in in Python or any analytics language which support which has potent libraries to support AIML technique based models, right? Then AIML product owner, obviously you all are we all are working in agile setup in pod, and now it's no more a buzzword, it's very pervasive kind of thing, how agile works and how what are the agile ways of working. So product owner will take the decision for the product wherever there's a the outcome is that product development or maybe product enhancement or product productionization support. A product owner work on Jira tickets, prioritize that. He would have a pulse on what my final stakeholders require from this product, right? He would know what kind of features, right, are desired out of this application or this product, right? It's not just analytical features or the complex machinery which is built in, but what kind of visualization, what kind of front end is required, how to put that or thread it together, how to weave it together to create a system which is a production system, right? So that is a product owner who will own that particular AIML product, right? AIML researcher works in new areas which I just maybe cursely pointed to, like new upcoming areas which will promote the further march of AI in the direction of travel. It will try to so that it will enhance and transcend the journey of AIML adoption, right? It could be explainable AI, right? It could be building the hybrid models, right? It could be uh, you know the AIML models with high efficiency, means compute low requirement of computing power, right? How to optimize those models. It could be model optimization, right? It could be model autonomous front to back autonomous uh, decision making, how to create. It could be how to uh, build a model into some kind of a robotic capability, so that tomorrow you could see that model taking those kind of decision which a human can do, which a human intelligence can do, which covers the many subjectivity within our intelligence, which is layered, like how we take judgment, how we do planning, how we do organizing, how we take our decisions, how to take a algorithm to that level of intelligence which is human intelligence, right? So a model validator would always challenge the model developer, AIML model developer and researcher, from the perspective of the regulators, from the perspective of the internal model guidelines, from the perspective of the risk management, that why such technique was applied in the first place, and if it was applied, whether it was adapted correctly, whether it was fine-tuned correctly, whether the hyperparameters of that technique has been tuned correctly. All these aspects are looked upon very granularly by a validator who would validate the model, whose approval is required before the model is adopted and productionized into the production system, right? So that's a role of AIML model validator, which will even become them. There will be more teeth which will be added to the AIML model validator, because now not only they have always a long tongue, right? I'm a validator, so I just mock our whole family that we don't just have the long tongue, we have the teeth growing more into what a normal human cavity has, right? Because the point is this: now AIML models, statistical models, are based on assumption, right? Within certain constraint, it they used to work, and before building those models, those constraints need to be respected by the data, by the technique, and every damn thing. AIML models are free spirited models, right? Right. So the challenge is that the challenge why a model being used for a particular problem set or data set, whether the right kind of maybe without building any spurious assumptions or correlations, or maybe some kind of a spurious data analytics, whether the insights produced by the data scientists give the right kind of indication or inference to uh, build this kind of adopt this kind of methodology or that kind of methodology. A lot of areas are there, even explainable AI, how somebody explain and interpret the model from a user perspective. If a credit officer or a credit underwriter is taking a decision, right, he needs a rating, he or she needs a rating, right, to give a loan, syndicate loan or some kind of a loan facility to a corporate. Whether he understand the constituents of the rating from the model, he understand how leverage ratio contribute to that rating, how liquidity ratio contribute to that rating, right, what kind of coefficients or weight, right, have been associated with different variables which are taken into the model, have they been explained well, do they have intuitive sign, do they have right kind of sizing, do they have right kind of balancing between qualitative and quantitative variables. There are a lot of areas for a model validator to keep challenging, and it will go on and on till the point that the models are adopted sensibly, because that's very important, that is very responsible AI. With with the advent of AI, a lot of people are jumping in the bandwagon, but including myself, including many others, but we should be very aware that these models, right, could create a mayhem as well, could be reason for the next crisis, right, because these would be taking decision in an autonomous fashion. If they would be blindly if they would be blind faith around how they are taking decision without even understanding what goes into it, and what is the attribution there, right, what is the performance attribution there, what is the explanation there, then it would be very difficult for somebody to nail down what led to the crisis and why a chain reaction would happen if there would be a crisis, right. Nobody would be able to trace back. These are completely black box things, and a model validator focus would be to adopt the model with very caution, a cautious approach and a measured approach. You prove me that these models could be explained, and if given such a stress scenario, such a maybe downfall or such kind of a market correction, these models will behave, they're expected to behave with the right kind of sensitivity, with the right kind of cyclicality, with the right kind of reactiveness, with the right kind of portfolio differentiation, they will behave, right. Okay, so if those tests would be passed, some of the statistical tests, I'm saying it from a layman perspective, that what all is the final criteria which we are looking at to validate the model, but some of the tests, statistical tests going into testing each of these very aspects, right, and then only the model will be adopted. And once the model pass through such scrutiny and such tests, I'm confident that few good examples will further with further enhance or enable or maybe accelerate the journey of AIML adoption, right. Okay, with few bad example, it would be a bottleneck, right, like a AIML model has been used, and tomorrow it created another issue, like you are hearing in European Union Commission, that it is discriminating against certain categories of people, right. Instead of AIML giving loans or giving credit in a dispassionate you know way, it is using the data after all, and it is seeing that which section of the society or cross section of the society is likely to pay more, it is giving only to them, right. It is not giving lending or even peer to peer community lending to those who are in the need of that kind of credit the most, right. So does such kind of discrimination also need to be taken care of, that it should not happen. We should follow some ethical standards around the built the wiring of these AIML algorithm, so that it would not, because it is learning from data. It is not to fault with, but the modeler behind it need to fault with. They should have provision, because anyway data would be biased towards the masses, and it would be very discriminatory towards the cross section of society which are non-bankable, specifically in a country like India, right. You would not give a loan to any rural areas which are already in distress, right. So such kind of things need to be taken care of, right. So this is maybe generally create maybe that kind of a wave which we would like to see. And just to put some numbers out there, right, based on some World Bank study, as well as some of the latest market prognosis or outlook uh, by McKinsey or Boston Consulting Group and those kind of consulting firms. By 2035, which is not far away, right? AI ML is expected to save 1.2 trillion in BFSI sector. It means that this is not cost saving. Don't read this number incorrectly. This is just efficiency gains, right? It means that it will bring about this much 1.2 trillion of, right? Maybe 1.2 trillion means a decent country which is in the low spectrum of growing up, the size of that economy will be the cost save of the banking sector, right? That's a huge thing. And it is accelerating rather, right? This number is not just stationary or stagnant. It is accelerating, right? With more use case being experimented with, and the proof of concept out there, and the models being built, they are adopted, they are used in real life scenarios. It is being accelerated, the adoption journey being accelerated. By mere 2030, this translates into 22% reduction in the cost, right, for banks. So there's no doubt about why bank investors or shareholders or CT1 providers, common equity tier 1 providers, they are harping on giving their money, signing their checks conditionally, that only if you have an AI strategy, I'll sign the next check. Otherwise, I have enough fintech companies out there. I'll try my money out there, right? So that's a investor pressure as well, right? Uh, Again, by you know the 2020, there is a recent report by World Economic Forum in 2020, which they published in 2020, which says that around 85 million jobs will be replaced by 2025, and we are seeing it at in next year, right? But it will create 97 million new roles. So in nutshell, there's an increment in role families, there's an increase in jobs which are being created. So net to net, it is employment generative, it is not employment regressive, right? That's the message, and that's what. So being a data scientist or being a AI ML aspirant, you should believe in data rather than any statements flying here and there. Uh, there are reasons. When there are reasons to be worried about something, there are reasons, right? It should be backed with data. But then when there are no reasons to be worried about things, it's only that you need to learn a skill and you need to be fasted to adopt that as a core competency, then so be it, right? Just have some conviction and do what is required to do. And India is any which way have always been the front runner of the IT revolution, and I would expect for AML revolution, India would again be the world leader, right? And we want that to happen very soon, right? The next thing is, I've covered these role families, that these are the prominent role families, and I have maybe segregated them and covered data science and AML role families separately. But the skill demand, now the skill demand is the low hanging fruits, uh, and some of the high hanging fruits. The low hanging fruits are data mining skills and data science skills prominently. As on date, if you have a data science skills or data mining skills, there are many takers of you even in today's market. You need not to wait, right? Somebody is there to pick you up, right? uh, and the other part is the algo building or algo developer skills, right? If somebody knows the programming well and also the technique well, right, at least from what steps are followed in order to build or create an algorithm, right? So there are enough takers of that as a low hanging fruit. The high hanging fruit is financial AML research, AML explainability, AML optimization, AML efficiency, performance evaluation, and efficiency improvements. That is the high hanging fruit, where people need to spend few years learning the skill, building it a core competency, taking some project exposure, examining some new use cases of AIML techniques, building their own carve out, specialization into a deep learning, because it's an ocean, right? Supervised learning, unsupervised learning, semi-supervised learning, deep learning, reinforcement learning, large language models, generative AI, building their own kind of a SME, it's not just obviously on a course like we conduct, you would be told everything, a plethora of cutting across all these different paradigms, or maybe approaches of machine learning, AI. But obviously you have to find choose your own area of SME expertise, right? Then obviously from an industrial application perspective, uh, the credit risk, counterparty credit risk, and portfolio risk, and market risk, and compliance and fraud risk, these are the low hanging fruits, right? Where already we have across banks, the JPMC, the Goldman Sachs, or maybe the Morgan Stanleys of the world, and especially the NatWest markets. They have in India also, they have a specified umbrella which where they only build hire data scientists and AI ML experts, right? But the other areas like stress testing and scenario, right? Uh, High frequency trading, derivative pricing, right? Chatbots, right? Anomaly detection, right? Or forensic audit, right? These are new areas where even more cases, literature studies, research papers, academia interest, industry academia partnership for to further deep dive into what kind of techniques we could build there is already you know lot of maybe uh, participation is happening, and on top of that some specialized companies are also building models there, right? So the next maybe stride would be in these use cases, so to say, right? So these are, but generally how it's being said is that as a AI ML expert, right, or a data scientist, these skills are not different. The depth into the skills might vary, right? As a data scientist, you need to be more deep into statistics. As a AI ML expert, you need to be more deep into mathematics, right? As a data scientist, you need more deep into the data, exploratory data analytics. As a machine learning expert, you need to be more deep into the technique, adaptation, right? How to make a technique adapt to a particular use case, right? So but the basic core skills are the computer science, or especially the hacking skills, how you hack your machines, because these are, as I told, these are very those kind of algorithms which require more computational power. How to hack your machines, how to make your computer, right, programmed to do the real time analytics or autonomous processing of these models, right? The mathematics and statistical understanding, obviously I explained there, and the substantive expert, which is subject matter expert. So we cannot discount the subject matter expertise, and it is all the more so important in the current context, because now, since these models are not driven by theory, these models are driven by data, and somebody who understand data well, who understand the relationship within the data, the domain of the data well, right, who knows, right, w- what is the intuitive understanding, how a leverage is linked with the uh, the earning at risk of a particular maybe company or firm. This kind of econometric understanding or economic rationale or intuitive understanding is very useful, because once the data is thrown to the machine, it will give all kind of insights. Some of those insights need to be discarded by somebody who's a substantive or SME expert into that particular area. So that's a key aspect there. So we should not. So those who are SME, I keep hearing that they always say that, okay, the machines will replace us. No, they will become even more important. To my understanding, nobody can replace them, right? The only thing is that they need to fine tune themselves into new ways of doing things, and that's where the uh, buck starts, and that's where the buck stops. And then maybe I'll take a pause here, and because I want this interaction to be a little interactive as well, and for people to ask their doubts, clarifications, and questions, and provide their feedback, and So I would like to open the floor for questions. Back to you, Nitish. Hi, Nitish, can you hear me?
Yes, yes, of course, we can hear you. So first of all, knowing how passionate you are about this, I mean, it was pretty engrossing and I mean, pretty informative as well. And I mean, we do have a lot of questions, but before going into the questions, maybe like again, uh, because it will help also address how to start, right? So maybe we'll showcase some of the work that we have done in this, right, very quickly, and then we'll go into the Q&A. It is like the session timing is like almost over now, so we'll quickly do the Q&A and then like I mean, but before that, just like allow me to briefly present what we have been doing, and that will help actually like people in getting into this field, right? So maybe let me show my screen. Is my screen visible? Right. So without further ado, actually, like again, just like a brief, and then we'll go into the Q&A, right? So, I mean, as an institute, we have been in the forefront of pioneering the quant education in India, including the fields of machine learning and artificial intelligence in finance. So that is what we have been doing for more than 1.5 decades, uh, building skilled man force for this field, consulting the industry. I mean, basically doing everything possible academically and in working with the industry to promote this field, right? So majorly those who are interested in building careers in all areas related to the advanced analytical areas of finance, be it financial engineering or quantitative finance, risk management, algorithmic trading. So we do have very deep certificate programs which are instructor-led weekends programs, and people can utilize this to build a strong career in this any of this field if they have an interest. And now, like again, going forward, we do have, I mean, also since AI and ML and data science, these are, I mean, have become very important areas, right? I mean, in the last few years, and I mean, as with finance as well. So we now have specialized courses for people targeting different areas of like the AI ML industry, right? So we have modularized courses as well, and then like the entire comprehensive courses as well to prepare a solid background in this field and make an entry, right? So I mean, in this actually, if you can see, then this certificate program in artificial intelligence for finance is like the whole comprehensive course comprising of modules on machine learning for finance, comprising of data science for finance, and also like again, if you're doing this course, then you can do a specialization as well. I mean, you can specialize in one of these areas, either in like AI applications in derivative valuation, or AI applications in trading, or I mean, Gen AI applications for finance, or AI applications in risk management, AI applications in credit, I mean, sorry, climate risk. So different areas of finance applications, you can choose one area as your specialization module. And I mean, of course, you'll do capstone projects on those specialization modules as well. The course in general teaches everything in context of finance, but this is something to go even more deeper on a particular area. Of course, you can select multiple areas as well, but one of the modules in this is like given to you free of cost along with the main course, right? Then again, if somebody wants to doesn't want to go into the entire field, right, and they want to maybe understand on a part of it, like they can consider it on the relevant areas of machine learning applications in finance, all the supervised learnings and unsupervised learning, deep data, NLPs and all that, right? And then its application in finance, or like one can go into the basic data science understanding of like again applications in finance, right? So understanding the statistics behind it, the models of data science, and going into your visualization techniques like all the visualization techniques like again Power BI and as Sanjay mentioned, even within the Tableau and all that, right? So this is something also one can do. So whatever is your requirement related to anything related analytics in finance, and particularly also related to AI and ML in finance, so these are things you can do, and then you can actually you can utilize this to either enter into the industry, or if you're already working in the industry, you can utilize this to deep dive in the specialized fields, right? And good thing is these are all instructor led online live lectures on weekends, so you can do these courses along with your job, or if you're uh, pursuing some degree programs, you can do it along with your degree as well. And yeah, it's been a 1.5 decade of journey. So a lot of professionals have gone through our courses and have utilized them to made wonderful careers in this fields of international banking or quant trading and machine learning applications, fintech organizations, big four consulting firms. These are some of them. You can go and like see their reviews videos to understand how actually you can utilize this courses for your furthering your career in this field, right? So the career track, I'm not going deep into this. Sanjay actually spent a lot of time explaining the career track on like what kind of roles and what kind of jobs you can target in the industry. So not going deep into this, which was already covered quite well. In terms of like the job support, yes, we do have a dedicated placement support system. It starts absolutely from the beginning. When you get in touch with us, we start by doing your career counseling if required, understanding your background and help you selecting what would be the right kind of knowledge base to choose, or what kind of courses will be useful for your aspirations and overall what you want to do and like basis your background. During the program and later on also we have this career mentorship by industry experts, the faculties, everyone is like a leading professional working in international banks and other financial institutions, or leading researchers from the AIML field in India, right? So it's a solid faculty pool who would be there to guide you, and you can seek their mentorships as well. There's a dedicated placement support team. Once somebody completes any of these courses, the team works with each individual on their profiling, resume building, LinkedIn highlights, and all, and then they target jobs in the relevant field, what basis on the profile and the course that one has done. Strong network of industry association. Ourselves being from the quant analytics industry, working like for more than 2 decades. The faculties, they're all leaders from the industry. The alumni, right? So essentially in the last 15 years, actually many of them themselves actually are like in very senior positions, right? And so yeah, the industry connect is pretty strong, and as I said, there's a dedicated team which regularly interacts with the industry to get opportunity. So yes, if somebody is wanting to use this course to build their career, there's a strong support there as well, right? So target companies also, these are things I'm not going deep, because anyway these are points which Sanjay has taken up quite deeply, right? Roles and responsibility also we discussed. A small list of names. It has been a long journey of like more than 1.5 decades now. So pretty much anybody working in this field we have worked with them in some capacity or the other, either trainers, consultants, or maybe recruitment partners. So these are people, again, a small list of people in companies we have worked with. And yes, the institute was formed to promote this quant and relevant analytical fields in India. So in our endeavor, we regularly promote this field amongst the educational institutions as well. Again, just a small list of like institutes we have worked with. NITI, which is IIM Mumbai now, IIT Madras, IIT Roorkee, BITS Pilani, IIT Bombay, to name a few. We work very closely with the academia as well to promote this field amongst in student community as well, right? So anybody getting interested in any of our courses, or like again otherwise also, if somebody needs a one-on-one guidance regarding career choice, skills, or anything related to this fields, feel free to reach out. We'll be happy to help, right? So yeah, let's quickly go to the Q&As. But before we go to the questions that has been asked, right? So I mean, couple of like questions which I would personally like to summarize, right? And based on a lot of questions which are similar. So there are some questions where people are asking that there are like again, I mean, AI and ML. These are fields which are applied to every industry nowadays, right? So is there any reason to, or like is there an advantage why somebody should choose AI and ML applications in finance? So why finance?
And maybe thanks, Nitish, for maybe moderating and putting the summary out there for variety of questions. But yeah, just let me get going with the first one. So the question is that why only dedicated to finance, right? Why this program, or in general, why somebody when this
The program, not about the program. It is a general question why again a person should think. I mean, when they're thinking of like building a machine learning career or a career in artificial intelligence, I mean, a
Mhm.
lot of people want to understand why finance.
Okay, no, I got the letter and spirit of the question now. Thanks. So the thing is that with other uh, industries and sectors, right? There's a limited leeway for AIML to achieve its zenith or
Okay,
pinnacle, right?
right,
Like in most of the heavy industries or manufacturing or mechanical sectors, what one could do, they could create AIML, but that would involve a lot of mechanical engineering, just like adoption of a robot for working in assembly lines, or maybe some kind of. So there's very limited use cases where they could do, and those are, I could call out those use cases as well, but those are limited to demand forecasting, uh, you know sales forecasting, or maybe the cost input management, right?
right,
Besides those fewer use cases, which anyway somebody would get to know in its depth, because it is not very dissimilar from finance, because when we do a forecasting in finance, right, it is much more nuanced, right? So that will become automatically very easy to kill kind of a use case, right? Which is very prevalent in other sectors. But the
right,
financial use cases, for a variety of reasons, are very complex, high dimensional, involving a variety of data, uh, and a variety of modeling techniques. So that's why if somebody would like to become a full throttle and a full bodied professional in AI and ML, then the finance is the area which they should first of all try to conquer, right? It would take time, but even with intermediate skills built there, they are already prepared by de facto for other sectors and industry. And that's not quite surprise why other industries and sectors are also tapping into the talent pool, data science, AI and ML talent pool, which are working for financial companies, right?
right,
So that's quite the case. It's similar to what happened to econometrics, 2 decades or 2.5 decades back, right? So whosoever required somebody who in other industries to do some economic analysis or demand and supply forecasting or those kind of things, they, or
right,
even the operation managements kind of thing, supply chain management, they ended up hiring from numerate fields, right? So essentially, by starting your career in numerate field, you have a trademark, equity, right? That you would be taken seriously by other industries as well, right? So that's maybe what I think about this. Yeah.
yeah, sure. So I mean, I hope that answers the question. Anybody having a follow-up question on that, of course, can put up in the chat window, and we'll be happy to take it up. But before going to that, another summary question from the other questions is like very quickly. summarizing like how to start building a career in this field. Some questions are related to which programming language. Commonly asked is like, again, why is it only Python, or like other languages are used, and like, again, if Python I mean, is that the language to start with? And in general about how to start a career. I mean, what is the learning curve actually, and what one should start with particularly.
Okay, maybe. Yeah, that's also a question which is very relevant for somebody who is starting the journey. And obviously, uh, the learning curve is a bit steep, right? For somebody who doesn't have, programming skills or mathematical skills or statistic skills. But that goes to your, maybe, to the candidate aspirations or to their own conviction to the course. Because we don't take it for granted, we are starting from ground zero. It means that even if you do not have any background, starting from your higher school into mathematics or probability or statistics, or even if you have always been fearing doing programming in one language or the other, right? We will start from very, very granular level skills, right? Even,
Correct.
our starting point like programming would not be just to get you into programming, but to start explaining you what are the design, overarching design of programming, the concept of programming, and other design thinking about programming, right? The second aspect is what programming language, what initial skills, initiating skills to start with. So the thing is that it is multi-pronged strategy, where some
Right.
of the preliminaries and prerequisites are taught first in the initial few months, right?
Right.
So that you would have a strong ground to build your foundation as we go forward. And it would
Right.
be deep rooted into statistics, probability, mathematics, programming, all put together, right? So the programming, the de facto language nowadays, as you have heard, is Python. And even if it is an alternative language like Julia or, Perl, it would not be much different in its scripting, so that could be adapted, right? But once somebody knows Python, right, uh, they could be build a skill there, they could build a real skill there, which could be adapted. The programming language might, in the future, 10 years after, the programming language might shift in other direction, right? There would be further advancement, but that would be more so to enhance the efficiency of programming rather than to change it, how it is, how the coding is done and how the script works, right? That, to my mind, would stay where it is, and that is already achieved by what Python has fairly stabilized, right? So
Right.
there would not be a radical change going forward once somebody would know the Python. As well as BI tools of today, they are pretty advanced. There would be few aesthetic features which would be added on top as in next decade or so. But once you learn about all the BI tools which are prominent today, it would be a very potent toolkit for you to have a skill for the future, like for eternal future. And the few tweaks here and there, few adaptation would always be there, right? So there's
Yeah.
the only constant is change. And I cannot say that this would not change, but this would change, but it would not be a radical change. Whatever was done radically, from moving from a low programming language like C++, Fortran, or maybe some of the heavy third party vendors languages like SAS or R, or maybe some of the open sources like R, have already been done a lot of work, and they have been, all the functions, all the different libraries have been built into the Python, right?
Right.
So that's, maybe, I think, there's a pretty much which you could cover for today, and maybe hedge yourself for the future, right?
Correct. Absolutely. Absolutely. And again, would you like to touch upon like the other basic skills like math stats, which one who can start with?
Yeah. So in mathematics, what we generally start with is the basics is differential calculus and integral calculus, and then we take it to a level where somebody could understand how differential calculus and integral calculus is used in a new evolving research area, which is a optimization of the model, right? So how some of the technique like gradient descent, which is based on differential and integral calculus, could be used for optimizing the model, right? So that is about mathematics. About probability, we would be telling you maybe you would be able to learn the frequentist way and the Bayesian way of probability, but also a new way of probability which will allow you to build some of the pricing models like risk neutral probability, how that under stochastic setting or a stochastic modeling framework is theorize what kind of framework are we talking about, what kind of probability are we talking about, how can create a pricing model which is arbitrage, based on arbitrage free pricing, right? Arbitrage free pricing theory. So we would be telling all those nuances of traditional models as well, which are which are very important, even if the modeling technique would change, but they would still be there, right? We would be telling the mathematics from that standpoint, probability from that standpoint. Similarly, statistics, there are some, as I talked about game theory and the use of Shapley values, you would be taught how the new correlations could be or multicollinearity could be handled, what kind of different validation tests could be performed on these AIML models, what are different techniques used to understand these models, to draw inferences from these models, to explain
Right.
these models using Shapley and game theory. So those aspects will be well covered into deep dive uh, on specific topics, as part of the curriculum. Yeah.
Absolutely. Absolutely. Right. So, I mean, I hope that answers most of the questions regarding this. But like I have like enough to go to specific questions. I mean, a couple of questions is from Karuna. So one, he has asked, I have some career doubts of modern fintech job skill set required. And second question is like, or rather, a continuation on that is that he says that is currently is working with P2P lending startup company, but he wants to learn about money management startup fintech culture. I'm also interested in venture capital fund. How to approach venture firms, sir? Okay. So before you answer that question, so we'll answer most of the questions, right? Right. But again, when you talk about interested in approaching venture capital firm, Karuna, if you can just clarify whether you want to start something on your own and then you want to approach the investor and all for that. So that's a different question altogether. But yeah, in that, I mean, in the meantime, if you can answer the other parts of the questions, anything you want to add on that, whatever you already mentioned.
So I think what Karuna, to my understanding, has asked is that for a VC firm or private equity firm, right, whether there's a application of AIML or are there fintech companies which are maybe galvanizing the AIML built up effort in that domain, like VC and
Right.
the private capital, right, basically,
Correct.
not the public
Correct.
markets. Yes, absolutely. Because even more so, it is relevant there because public listed firms would have their stock market data and all the time series available. But what about how to value a company, right? Which is a private firm which has not yet gone, to the public markets, right? You would need some kind of a very data driven approach to value them and to find the fair value of the company, right?
Correct.
Right. So obviously the valuation part, the company valuation or the firm valuation, whether it is discounted cash flows or some kind of a multiple base, right, is hinge on the fact that, right, what kind of data you use to value the firm and alternative data set. Like for
Correct.
most of these firms, you cannot simply ascertain their sales, their revenue, and that's where most of the VC firms or PE firms fail to put a number there, what kind of multiple they should enter and what kind of multiple they should exit, right? So a kind of alternative data set, like there are use cases, there are literature papers which says that by using the geo satellite data, and seeing the parking lot, how many cars are parked on a peak day in a particular Tesco store or in a particular retail store, one could examine that what would be the sales forecast of that particular store. And if you put calculate the store wise store sales forecast of 100 stores, you could put a number there that okay, this is their revenue, forecasted revenue or projected revenue, and this is the multiple you would like to pay for if you are if your multiple is based on revenue or sales, you could put a number there, right? So such kind of models could be built. The VC firm and private equity firm, are they doing it? Yes, in bits and pieces they are, obviously yes they are doing it, right? But the point is this, that it requires a lot of synthetic data, it requires a lot of non-modern data, right, to further corroborate the effort, to further accelerate the journey, right? And that's where somebody who is honing the skills of a data scientist or AI/ML expert will be very precious to such companies, right? They would obviously be hiring such people more in the coming maybe near terms, so that they could build such capabilities to ride on the wave of AI/ML, to do this particular valuation more scientifically than more subjectively, which is currently the case. Yeah.
Okay. All right. Wonderful. Yeah, yeah. So that's like, I mean, so basically, like again, that answers the next question as well. I mean, a lot of it, because next question is from Samrat, and he mentions that he is in equity research uh, for almost 8 years and ESG research for 2 years. So question is, will AI be used only for fintech roles, or non-fintech roles can also use AI? So since he is from equity research and ESG industry, so a part of it, I think you've already answered. I mean, how can it can be used in company valuations and I mean, venture funding, capital funding, and all that, right? So anything you want to add for him?
So ESG modeling is a new ball altogether, which is being played in last 6-7 years with EBA and other regulators forcing for the climate risk and sustainability norms. Now the thing
Right,
is that somebody who is into equity research need to make ESG variables part of their equity research, right? And that is not well embedded. There are bits and pieces, few variables added there, but ESG variables are a whole sort of different variables analyzing physical risk, transition risk to that business, uh, coming from the climate risk topic, right? So these need to build some actuarial, integrate some actuarial models or
right,
insurance like models, which will create an integrated framework for doing the equity research, or for picking the stock market pulse of the stock market, where is it going. Not only that, the public markets now is going through a different kind of regulation, where in future ESG norms will be the main criteria for the big funds, right? Especially the regulated funds like pension fund, endowment fund, even maybe some of the other funds as well, like maybe sovereign wealth fund, to invest their money into such companies or such particular sectors or such particular industries where the ESG clearly tell that those sectors, industries and companies are moving away from high carbon footprinting to low carbon economy or zero carbon economy, zero carbon
right,
emission economy, right?
right,
So that's why there's a lot of scope here, because there are two parallel tracks here. Somebody who need to build a capability there need to understand the climate risk well, the climate and sustainability risk well, and use the AI/ML techniques to integrate the climate and sustainability scorecard and build it into their equity valuation or equity pricing models, right?
correct.
So obviously you are at a sweet spot, and for those people like you, AI/ML would really be a game winner or game changer, right? Because obviously you have been a domain experts on either side of the things and exposed to both sides. Now that how you could integrate them well using the new technology, which is the AI/ML way of doing it, that's even more becoming relevant for somebody who is already there, right?
Yeah, absolutely. Absolutely. So, I mean, Swanand, I hope that answers your question. Any follow-up, please feel free to ask. Okay. Now, going in, sorry, this question was not from Swanand. My apologies. This was from uh, Samrat, actually. Swanand has a question. The next question is actually from Swanand. Sorry, Swanand. Right. So Swanand's question is like, given the traditional quant model drawbacks that you mentioned, is it useful to learn these statistical models, or should we focus now on only just on AI model creation?
Okay, that's a very good question, and though it sounds like a very obvious question, but it is still the most relevant and important question to the era we are living in. Should we completely discard the old techniques and you know attune ourselves to the new way of doing things? The new way of doing things has its basis in the old way of doing things, right? You need to understand those models as well, this model as well. I'm not advocating for one way or the other, right? Because the starting point is that the currently adopted uh, way of doing modeling and the regulatory acceptance there, and this, you as an AIML expert is challenging that, right? For you it is also more important that to understand how the statistical regression model, OLS and the MLE, do their work. It is also for you to understand how the workhorse of logistic regression and some kind of probit regression or some kind of different form of classification work there, how old time series work there, right? So we would not be leaving that thing, just ignoring and neglecting in some dark corner, right? We would be our starting point would always be starting with some statistical model, regression model, and then it is for you becoming rather than somebody telling you that okay, these are the advantages of AIML, you will figure out the pros and cons and the merits and demerits yourself, right? Some way you would also might be intelligent, grow some intelligence to do a hybrid model, right? Using a traditional method as well as a machine learning method together under one model, right? So that
Correct.
is also a possibility. So we would not just try to stereotype and you into building a skill in one direction, forgetting what has already been the plethora of base groundwork which is already there. So you need to have a foundation, and that foundation goes into understanding the traditional way of doing modeling as well. Yeah.
Absolutely. Absolutely. And just to add, actually, like again, in any industry that you work in, I mean, I'm not necessarily talking about like quant industry, right? So essentially, whether you, of course, like again, since machine learning, using machine learning models will have its advantages. That's why these are like becoming so prominent. But that does not mean that you stop understanding the core knowledge, I mean, or core domain. Without understanding the core domain, the models that has been traditionally used, or the, I mean, and understanding the theoretically the industry as such, you cannot apply machine learning out of thin air, right? So you have to understand the domain first, and then only you understand the machine learning, and then you progress. And again, and that is how you grow in the industry, right? But again, that is true for any industry. Whether you, I mean, of course, even if you're using machine learning and all, first you have to understand that domain first, right? So yeah, going into the next question, which is from okay. So Sanjay, I mean, we are already half an hour uh, extended actually on the time that was allocated. So now the next 2-3 questions very quickly, and then we'll wrap up the session. So the next question is from Vivan, and he has asked, how far are we from quantum compute? Sorry, my apologies. Quantum computing. His spelling was like wrong, and I spelled it like that. So apologies for that. So how far are we from quantum computing, and what impact you are visualizing on finance domain?
Okay.
Would you like to?
So Vivan, maybe you played to my tunes, right? That is even in fact an area which I am also generally interested in, right? So quantum computing has taken a leaps, right? Because the creation of a quantum computers so far has been very industrial, right? And right, it's not commercialized to a scale where it could be adopted. But the next decade, if you are trend picker, right, the next decade would change right? And would further enable the AI/ML adoption through the use of quantum computing as well. So that would be the last nail in the coffin for the entire market to move in a direction and to consolidate AI/ML capability, the creation of quantum computing as a reality. And the obviously the point is that the the dearth of chips, and you know that, from semiconductors industry, the dearth of chips, even we are struggling with 5G computers, the dearth of chips is a roadblocker. But now I recently heard that some of the capability which is building into China and other economies, and even in India, there's a focus on semiconductor, maybe uh, or the chip creation, right? Because once those chips are readily available, you could build a quantum computer, right? So specifically for deep learning, linking it back to AI/ML, specifically for deep learning and for reinforcement learning paradigms of AI/ML, the quantum computing would nail it, right? Would just make it reach its optimal potential, right? And that's where the game changer lies, that's where the radical change lies and the transformation lies, right? So I'm a believer, generally I'm an optimist, so I feel like it is no far an idea, with people adopting more and more, enterprises are adopting more and more AI/ML built solutions. The next bottleneck when they face about the computing power, right, they will be ready to have the demand placed. And if there would be demand, definitely the market forces will play their invisible hand, there would be supply, right? So it's just it's not nascent, but just the AML adoption stage, which has to reach a particular level inflection point where it is capped by the computing power. When it reaches there, right, there would be heavy demand on quantum computing. And once there's a demand, there would be industrial supply at commercially viable rates, right? And then obviously the next maybe stage would come where the AI/ML will come in its full throttle force, brute force, what we call, right? So then we would the ascendancy of it would no more be a dreamy, it would be fulfilling, right? Right.
Correct. Yeah, absolutely. That's very well explained actually, right? So, going to the next question. I mean, in fact, this is the last question we'll be taking today, because other questions has been summarized and taken up in like either in the summary question or like the questions that we have uh, taken up before, right? It's a follow-up question for Samrat, and again, this has also been discussed, but again, he has asked, like, again, he being from core equity research, yeah, has done his CFA, also he has started learning Python few weeks back. Congratulations, Samrat, first of all, being from pure finance background, having that vision that, like, again, to get yourself I mean, equipped with all the futuristic knowledge, right? Because not many people are from equity research, I know, are like, again, still learning Python. So that's great. I mean, it shows your vision actually, to be honest. I mean, and then getting used to, or like maybe learning all the technical things that would be needed, right? So what kind of AI/ML what kind of AI/ML career will be right for me? So that's his question, being from pure corporate finance background into equity research.
Okay, I think there are several viable options, right? I'm not going to do all the Monte Carlo simulation and build different paths, but I could tell you few of the viable option had I been in your role, what I could aspire for. So algorithmic trading and high frequency trading are the natural, follow-ups, right, for you. Fund risk or fund management or portfolio management are, if you want to build your career on risk management side, then fund risk or fund management and portfolio management are the second uh, areas which you could look as something called green postures, right? Then there's an area within equity research which is more tilted towards, as I said, climate risk, only climate risk, right? Very climate risk and sustainability risk focus, right? Which is into carbon trading, the pricing of carbon credit, right? So the carbon trading and some of the instruments which will be created there, right, will have more or less same pricing kind of theory which you enforce while doing your equity research, right? So that carbon trading pricing is another promising area where you build your career. So I'll club it, maybe I'll just summarize this: carbon trading, which by which I mean climate and sustainability risk pricing, right, or risk premia pricing, right? Then your the area which is basically algorithmic trading or high frequency trading, right? The area which is fund strategy and fund risk, and as well as the portfolio risk management, right? So these three areas set you right, whichever way you go based on what you are interested in. But these are the natural progressions for the career, for the next stage in your career, right? As far as I think, yeah.
Yeah, I mean, those are definitely quite good options, Samrat. Of course, it is not exhaustive, as Sanjay has mentioned, but these are definitely good, very great, I mean, great suggestions. Right. So, okay, now before we wrap up, like quick question from Naveen: how many days will the certificate be sent to the email? So Naveen, the certificate will be download. You will be able to download it from the LMS itself. So maybe in the next 3-4 days, it will be there in your LMS. So once it is there, we'll send you an email intimation as well. So you can download the certificate from there. Right. So, okay. So with that, I think it has been a pretty exhaustive session, Sanjay. I mean, thanks so much. I mean, it was pretty informative. Though we, I think, surpassed the time a little bit, but I mean, when the session is so engrossing, I mean, you don't even realize. So thanks to the participants as well. I mean, you have been very patient. Of course, it shows your interest, and again, I hope that like it also shows that we were covering something right. So I mean, keep track of all the future webinars that we continue doing as a part of our deep dive with IIQF experts webinar series. Keep track of us in the website, in our various social media pages. Of course, we'll intimate you over emails and other modes of communications as well whenever we announce the next set of webinars. In fact, the next set of webinar will be like a panel discussion on the generative AI applications in finance. So would be pretty interesting. Most likely it would be in the second last weekend of this month, right? So we'll be announcing it probably in the next couple of days. So keep track of various communication channels, social media pages. See you again in the next webinar. Thanks everyone for joining, and once again, thanks Sanjay for I mean your time. It was really a great session. Thank you.
Thanks all, thanks for your patience, and keep you motivated and enthusiastic to move forward. And I hope that we will cross each other's path very soon. Yeah.
Wonderful. All right. So, I mean, with that, let's conclude the session for the day. Thank you.